Good afternoon, friend. In my last lectures, I explained the two factors who's affecting a chemical shift value, and in this video, other factor are also present. Van der Waals shielding. What is a van der Waals shielding? And how can affect a chemical shift value? Van der Waals shielding is also called a steric effect. Through the my image, it's a first compound and it's a second molecule. In first molecule, this hydrogen atom, this hydrogen proton, this hydrogen proton, and this a methyl group. Okay, but this group is not a very bulky compared to this group. This group is a very bulky, and because of a presence of a very bulky near to a hydrogen proton, create a electrostatic repulsion between us, and because of a electrostatic repulsion, this proton give a high chemical shift value. And hydrogen bonding is also affect a chemical shift value. Through the my image I will explain. This proton is a hydrogen bonding. This is a hydrogen bonding between a hydrogen and oxygen. Here is a highly electronegative, and this atom is also highly electronegative compared to hydrogen, and hydrogen is between this and this atom as a sandwich type. Okay, and because of this presence, hydrogen this oxygen is attract to hydrogen electron towards it, and this oxygen is also attract to hydrogen electron towards it. So this hydrogen atom not have a sufficient electron around us and convert into deshielded proton, and because of a deshielded proton, this proton give a high chemical shift value. Hydrogen bonding is also affect a chemical shift value, and hybridization is also affect to high chemical shift value. Because of a hybridization, the carbon attached with hydrogen atom, for example, it's a sp2 hybridization and it's a sp3 hybridization. In sp2 hybridization, s character is a high compared to sp3 hybridization, and because of a high s character, carbon attached to a hydrogen atom is hydrogen atom is a very near to carbon atom in sp2 hybridization compared to sp3 hybridization. So because of a hydrogen is a very near to carbon atom, so carbon attract to hydrogen atom in a very high attraction, and because of that attractions, this hydrogen for sp2 in sp2 hybridization, hydrogen not have a sufficient electron around us. So this hydrogen are deshielded and give a high chemical shift value, and it's a chemical shift value. For sp3 hybridization, chemical shift value is a 2 to 5 pm, and for sp2 hybridization, chemical shift value is a 5 to 8.5 ppm. Okay, thank you, friends, and in my next lectures, I will try to explain many other things related to NMR spectroscopy. Okay, thank you.